Hola, ¿y cómo estás? Yes, that is sort of the limit. How is everybody doing today? We are MSM3 and we are looking at Unit 2, Lesson 2, ordering rational and irrational numbers. So we have to understand, what does a number mean and how can we compare it to the other ones? So for example, if we wanted to order this following set of decimals from least to greatest, we need to know that 0.82 means that only the 2 is repeating. 0.822222 and so on. We need to know on the second one that 8, 2, and the 8 are repeating. 0.828828. It sounds a little bit sing-songy. That helps me. 0.82 means that the 8, 2, 8, 2, 8, 2 are repeating. And last but not least, this one has no repeating bar, so it is worth exactly 0.822. And if you wanted to compare to these other numbers that are longer, you can just put zeros on the end and no ... So when we are comparing, we're going to look at each digit one at a time. So the first thing we're going to look at is 0.8, 0.8, 0.8, 0.8. They all start with the same digit. So now we're going to look at the second digit. They all have 82, 82, 82, 82. That puts us at the third digit before we can start making any sort of decisions as to who is the largest number and who is the smallest number. So this one is 822, and this one is 822. Those are both smaller than the ones in the middle that are 828. So I'm only going to look at the two on the outside. 822 and the next digit is a 2. 822 and the next digit is a 0. That makes 0.822 the smallest, because the fourth digit is a 0. That makes 0.8 with only the 2 repeating next, second place, because it is the next smallest. Now we've got 828, 828. What's the next digit? This one, the next digit is a 2, making 0.82 repeating, third place. And 828 followed by another 8, 0.828 with all three of the digits repeating, the largest number. You'll notice that my final answer has the repeating bars in it. I did not write out my final answer with all of the digits. Order the following numbers from least to greatest. So same idea. What do I have for numbers? 2 and 5/9. Now the easiest way to compare them is to put them all in the same form, either all fractions with a common denominator or all decimals. I'm going decimals. So 2.59 is a 5 repeating. Negative 4.1, well, not very interesting. Negative 4.1, and if I want to put some zeros on there, I can. Don't forget it's negative. Negative square root of 20. Now, if I'm going to estimate that, it's going to be between the square root of 16 and the square root of 25, making it somewhere between 4 and 5. It's a little closer to the 16, so I might go something like negative 4.3 or 4.4. And then we've got 2.5151 with all 4 of those digits repeating. So 2.5151, 5151, and so on. And last, 2 root 6. Now, what did we do with that? We squared it, and we got 4 times 6, or 24. And then we had to simplify the square root of 24, which is between 16 and 25. Notice it's positive. We're between 4 and 5, super close to the 5, right? 24 only one away from 25. So I'm going to go with approximately 4.9. So at this point, I'm going to say they're all in decimal form. I can add on some zeros to some of these if I need to for comparison reasons, but I've only got one negative 4.1 and one negative 4.3 on my list. They're going to be the smallest because they are negative. So I'm going to put them down sort of at the bottom, negative 4.1, negative 4.3. Which one's furthest away from 0? Negative square root of 20, or negative 4.3, is the furthest from 0, furthest to the left on a number line. So negative square root of 20 is the smallest. Negative 4.1 is next. So I've kind of got those off my list. 2.5, 2.5, and 4.9. So the 2.2, those are my next smallest. 2.55, 2.51. So I'm going to go with the 2.5151 repeating because of the 1. Now I've got 2 and then only 5. So that's my 2 and 5/9. Last is this weird one over here that was positive, that was up almost to 5. 2 root 6. So I will cross them off as I go. I will compare digits. Negatives always coming first to the left because they are lower than 0. Positive numbers to the right because they are greater than 0. Fill in the blank with greater than, less than, or equal to, and show your work. So square root of 35, I can say that that is sort of between 25 and 36 square rooted, between 5 and 6, really close to 6 or about 5.9. 3 root 3, that one's going to take me just a little bit more, right? I have to square it. I'm going to get 9 times 3 or 27. Square root of 27 is just a little bit higher than 5. Square root of 27 would be 5. So maybe this is about 5.1 or 5.2. If I add those together, I'm a little bit higher than 11. I know that the square root of 169 is exactly 13, making 13 the greater number. So remember, it doesn't matter if one of you put 5.8 and I put 5.9, or one of you put 5.1 and I put 5.2. It's an estimate, and it's definitely lower than 3 when you add those together. So the square root of 11 squared, recall that the square root and the squared cancel, and I just have 11. Square root of 119 is going to be really close to 121, much closer to 121 than it is to 100. So between 10 and 11, almost to 11, we might say 10.8 or 10.9, which is smaller than the 11 that I have on the left, right? We know the square root of 121 is what we would have needed, and we are lower than the square root of 121. In mathematics, a set is a collection of things. The things in the set are called elements and are listed in braces. If I were to list the elements of the set of Starburst flavors, the set would look like this. And I might even want to say the set of original Starburst flavors just to be specific. But the braces are these symbols here. And your list goes inside the braces. So strawberry, cherry, orange, and lemon is the list of things or elements that fit the category, the set of Starburst flavors. Sets are unordered, so the list of elements could look like this. It could be in a different order. Maybe one of you really likes orange, so you remember to list orange first, and someone else really likes strawberry, so they put strawberry first. Doesn't matter. List, using set notation, the main characters of Toy Story. There might be a few discrepancies here, but most people would agree that Woody is a main character, Buzz is a main character, and Andy is a main character, and the rest would probably be considered supporting characters. Yes, go ahead and argue if you want. Jessie, if we're talking Toy Story 2, but we're only in Toy Story. List, using set notation, all positive integers less than 5. So whatever I write has to be positive, and it has to be less than 5. So an integer that is positive 1 is a positive integer, 2 is a positive integer, 3 is a positive integer, 4 is a positive integer. I'm going to stop because I need less than 5. And you'll notice I didn't put 0 on my list because 0 is not positive. List, using set notation, 5 rational numbers less than 1. Now, it doesn't say which 5. So this is just any 5 rational numbers. Again, order doesn't matter. So on the previous one, you could have put 4, 3, 2, 1, and I put 1, 2, 3, 4. That's fine. Anything that is rational. So I could have a negative number. I could have 0. That's rational. I could have a fraction. I could have a decimal. I could have a repeating decimal. And you could have completely different answers than me and still be correct. Last but not least, onto the back. Which set consists only of integers? So remember, integers, no fractions, no decimals. So this one I automatically know is a no because it's got a fraction. And this one I know is not integers because it's got a decimal. And this one I know is not all integers because it's got a decimal, leaving only option C. 0 is an integer. It is whole numbers, positive, negative, and including 0. Excuse me. Which set consists of only rational numbers? All right, so square root of 196 is worth 14, 9, negative 7. Now this one, can I write it with a repeating bar? 1, 2, 1, 2, 2, 1, 2, 2, 2. Nope, I cannot use a repeating bar because the pattern is not consistent. So I've got 3/4, negative 10.1, 0, 0.7 repeating. This one looks very promising. I've got a repeating, I've got a fraction, I've got a decimal. Those are all good because that decimal is terminating, right? It stops. If I look here, square root of 164 is going to be a problem because it's not a square number. And if I look here, I've got another one of those really long decimals that cannot be written with a fraction bar. Cannot be written with a repeating bar. also cannot be written as a fraction, meaning that option B is our answer for rational numbers only. Can't wait to see you in class.